Hey you guys, welcome back. Today we're going to be talking about outliers in data sets. Make sure that you've printed out these notes from Google Classroom so that you can follow along or write them down on some blank paper of yours, okay? First things first, this beat the test question is actually from the last section, so we're not doing that in this lesson today. And you need to make sure that on everything that you submit, you're putting your name, the period number that you're in, and also the date, which is the 17th, for that assignment. Okay, so let's talk about outliers. So this question says, a survey about the average number of text messages sent per day was conducted at a retirement home. And that ranged between 5 and 15. There's the data set. The mean for this data is 8.7, the median is 10, so they've already calculated that for us. And then we have somebody named Grandma Gadget. Love that name. Grandma Gadget is up to date on the latest technology and loves to text her 25 grandchildren. She sends an average of 85 texts per day. Her data point is substituted for one of the original data points of 15. Okay, so the new data set looks like this. It's almost exactly the same as the previous one, except what they're saying is now, instead of one of these people who was only sending 15, we're going to count Grandma Gadget who's sending 85. Okay, so that's the only difference in the data here. Which measure of center will be most affected by substituting Grandma Gadget? Will it be the mean or the median? And justify your answer. Well, let's think about something. The median of the first data set, they already told us, is 10. And let's look at the second data set and figure out what the median is of that data set. Well, if you think about it, the median has not changed because the median is just the middle value of the data. It doesn't really matter what the other values are. It doesn't matter that we now have an 85 on the end. If you strictly look at what's the middle, 10 is still the middle. So the median has not been affected at all. Now the next question is the average going to be affected? So let's make a note. Let's make a note that the median is unaffected. And then let's make a note of the first data set. Mean was 8.7. They told us that. And then the mean of the second set we need to calculate. So let's go ahead and do that. That's going to be 1, 2, 3, 4, 5, 6, 7 times 5 is 35. 1, 2, 3, 4, 5 plus 50 plus 30 plus 85. And we take all of that and divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 people. Oops, it was 200 and we're dividing that by 15. So the mean is now 13.33. So the answer is the mean is more affected by switching out this data point, by adding this 85 at the top of the data. It affected the mean, but it did not affect the median, because median is a measure of center based on the placement of the values, and the mean is a measure of center based on the actual averaging together the values, adding them up and dividing by how many you have. The next question says, does Grandma Gadget's data point have a greater effect on the standard deviation or on the interquartile range? Justify your answer. Well, if we think about the interquartile range and the standard deviation, let's think about the interquartile range first. The interquartile range for the first data set is going to be, let's see, we said there was 15, right? So that means I have 7 on the bottom, 1, 2, 3, 4, 5, 6, 7. And this is the median, and then we have 7 on the top. So the middle of the bottom half is 1, 2, 3, and here's the middle. This is Q1, is 5. This is the median. And then the middle of the top, 1, 2, 3, 4, that's this one, Q2. that's going to tell me my interquartile range. It's Q3 minus Q1. So I don't know why I put a 2. Sorry, Q3. Q3 is 10, Q1 is 5, 10 minus 5 is 5. So the interquartile range is 5 for the first data set. If you look at the second data set, everything is in the same exact position it was before. The only thing that's different now is the very last piece of data here is now an 85 instead of a 15. But what that means is that my Q1 and my Q3 are still going to be 5 and 10, and my interquartile range is still going to be 5. So the interquartile range will be unaffected by the fact that we now have this huge number at the end, which is 85. So my guess for this answer is that the standard deviation is going to be more affected. And let's think about why that is so. Because in the first data set, the mean is 10. The average is 10. The mean is 8.7. That was told to us. And then all of the other values are pretty much clustered around this, this 8.7 value. None of these values is particularly distant from 8.7, so this is probably going to be kind of closer to like a normal bell-shaped curve if we were to graph that. If we look at this data set, though, we now have an 85 tacked on the end, which is super, super far away from the original average of the data. If we average the second set, we did it already, we get 13.33. 5 is not super far from 13. 15 is not super far from 13, but 85 is super far from 13. And remember, when we're talking about how far data points are away from the mean, we're talking about the spread of the data. And so the standard deviation is going to definitely be affected by that. Standard deviation is going to increase because 85 is super far from the average. Alright, so let's go ahead and turn the page. We're going to do one or two more example situations here about outliers. We're gonna call Grandma Gadget's data point, that 85, that is an outlier, and it's a value that it's an extreme value, and it's very distant or far away from the others that are in a data set. So let's practice. The table below, the table that we see here on this page, it lists the number of customers who visited a car dealership during 30 randomly selected days. So this is telling us on any one of these given days how many customers went to the car dealership. So the first day they looked at, it was 26, second day was 29, so on, so on, so on. Identify the outlier and describe how it affects the mean and the standard deviation. Well, if we were to look at this list, most of these values appear to be, they look to me to be like mid-20s, high 20s, low 30s, maybe even up to like mid-30s. That seems to be 36, 37 seems to be the highest value that I see here. So they're all somewhere between like 20. Let's see, what's the smallest one here? Well, 11 is the smallest one, but we're going to get to that in a second. It looks like most of the data values fall between 26 and 37, so somewhere in that range. But on one particular day, there was only 11 customers, okay? So take yourself out of the notes for a second and just think about this. If I told you that on this one particular day, only 11 people showed up, would you say that that is comparable to the average number of customers that shows up? And you should be saying no, that's an abnormal day. Most of the days is somewhere between 26 and 37, it looks like. So somewhere in that range of like plus or minus 5 or 6 customers from the middle. But this particular day there was only 11. Now you could think of probably 100 things that could cause that to happen. maybe there was like, some natural disaster that day. Maybe there was some kind of holiday happening that day. Who knows? But that day there was only 11 would be considered an outlier. It's much further away from the rest of the points in the data set. So we're going to identify that the outlier is 11. And let's describe what happens to the average, the mean, and what happens to the standard deviation. Well, since this value is so much smaller than the rest of these, if you were to remove this, then the average would be high, okay? Somewhere, between, in the 30s or something. When you add this in, it brings the average down. It's kind of similar to how, for example, if you were to think of this as like test scores, okay? Most of the people are getting, A's and B's, but then one person gets an F. That brings the average for the whole class down. It lowers the average. So this outlier being less than the rest of this data means that the average is going to decrease. And then finally, the standard deviation is going to increase. And let's think about why that's happening, okay? If you were to remove this 11 from the data set, all these values would be, within a reasonable amount of space from each other, 5 or 6 to the left or the right, plus or minus, okay? When you add in 11, that means you have a data point that's super far away from the mean, and so that means the standard deviation has now increased. The average that the points are away from the mean is going to be larger. There's more distance happening there. Okay, so we're going to do a try it question. Here's what I want you guys to do. I want you to go ahead and pause the video. I want you to read the problem, look at the data set, and think about what your answers would be to some of these problems, okay? And then we're going to go over it together. So go ahead and pause the video, and then we'll come back. Okay, we're back. So in the try it question, it says, the students in Mrs. Gomez's class were surveyed about the number of text messages they send per day. The data set is as follows. So 0 all the way up to 50. So we're talking about text messages again. They love text messages in this one, I guess. What value would you say is the outlier? And I hope that you said 0, okay? Because 0 is super different from the rest of these. These all are somewhere between 24 and 50, okay? All these values fall between 24 and 50, okay? So there's a distance there of, what is that, 26 spaces. So within 26 spaces of each other, all these data points are falling. And then you have somebody who's sending none. Okay, so if you were to take the 0 out and average these, you'd probably fall somewhere in like, the mid-30s or something. But if you add the 0 in, your mean is going to go down, and you're going to have somewhere maybe in the 20s now, because there's someone who's bringing the average down by not sending any texts. How does the outlier affect the mean? It decreases it. And how does the outlier affect the median? Well, remember, the median of a data set is just whatever value falls into the middle, whatever it is in the middle. So just because this is 0, this could be 10 or 15 or 20, it doesn't matter. That's not changing the position of any of these numbers, so the median is going to be the same. It does not affect the median. Okay, the next question says, which measure of center would best describe the data, the mean or the median? Well, the one way we can look at this is we can look at the answers to our last two questions and decide, is the mean being affected by the outlier or not? And is the median being affected by the outlier or not? And we've already decided that the outlier doesn't affect the median at all. So if we're looking just for the measure of center, the median would be a better choice here because it's not going to be pulled at all by that 0. So we're going to put the median. It's unaffected by the outlier. Okay, next question. It says, how does the outlier affect the standard deviation? So remember, the standard deviation is a measure of spread, how far the data points are away from the average or the mean. And if you have most of the data is a certain number of data points away from the center, like taking out the 0 and just looking at the rest of these, then you suddenly add in this 0, which is super far away from the middle. Now all the data points are just a little bit further away from the center, so it increases the standard deviation. Next question is, how does the outlier affect the interquartile range? So remember, interquartile range has everything to do with the positioning of the numbers in the set, and it has really nothing to do with the actual values of that data. So if I were to look at the interquartile range here, it's not changing just because I have a value of 0 at the bottom here. Okay, how many data points are there? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so that means if I go to the middle, cross, 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 cross. Okay, so 35 and 35 averaged together is 35, and that's going to give me my median. Okay, so the median is 35. And then my interquartile range will be from 0 to 35. What's the median of that data set? So those go out, those go out, those go out, and these two need to be averaged together to find Q1. So Q1, 28 and 28 divided by 2 is still 28. That's Q1. And let's do the same thing on the top of the data. So 35 and 50, 45 and 36, 38 and 42, 39 and 42. So we need to average 39 and 42 to get our Q3. And when we add those together, we get 40.5. Okay, so that is our Q3 and our Q1. And if we calculate the interquartile range, it's 40.5 minus 28, which is going to be 12.5. So the IQR is 12.5. It's Q3 minus Q1. Now, does the outlier, the presence of that outlier, change anything about this? Well, if this number, this 0, was 10, it would still be considered an outlier because it's pretty far away from these other data points, and it's still in the same positioning. And then, therefore, my Q1 and Q3 aren't changing at all. In fact, if you change the outlier to be a different value that would fall somewhere in this range, like maybe the outlier, instead of being, maybe we take out 0 and we add someone else in who's sending 30 text messages, then I would have two 30s, and then my Q1 and my Q3 would be affected. But just the fact that the 0 is here is not affecting my it's not affecting my interquartile range at all. So it doesn't affect it. Okay, last question. What measure of spread would be better to describe the data? Is it the standard deviation or the interquartile range? Well, we want to pick the IQR here because it's not being affected by the outlier. So the IQR is best because it's not affected by the outlier. Okay, so that is that's basically the gist of what we're talking about when we're talking about outliers. They're extreme values that are very, very far away from the rest of the data that's in the set. So what I want you guys to do now is going to be the assignment that I post in Google Classroom that goes along with this. You're also going to have to take and submit a picture of your notes for a grade. And if you have any questions about the lesson that we've covered today or anything else from stats or just in general, please come to my office hours. Those are Tuesdays and Thursdays from 10:30 to 1:30. The code will be posted on Google Classroom so you can join. I'm there 100% of those 3 hours. You might jump in the room and you might not see me right away. That's fine. I'm here in the background. Just scream out, scream for me, and I'll come back to the room and help you out. Okay, I hope that's been a good lesson for you on Outliers, and I will see you next time. Bye.